Hello, this is Shane Silsby. Welcome to another episode of the Public Works Podcast. Today, I had a great conversation with the General Manager of Orange County Sanitation District, Mr. Rob Thompson. We had a great time chatting about what's happening with their agency. We did a tour of the facilities, we talked to some of his team members, and we talked about the future of the agency and what his thoughts are on innovation, project delivery, financing, and culture for today's leaders. Outside here in front of their new headquarters building, which is one of the things we talked about, we can see the way pipe is implemented now with a precast solution. Then behind that, you can see how pipe was done back in the day where they actually built it out of pieces on site. So you can see the size here as we go through this larger pipe down to what used to be done in the field through individual components here. And behind is the new headquarters building that we spent some time in today for our interview and as part of our tour. Hope you enjoy this episode. Stay tuned afterwards for some special videos from our site sewers. Thanks so much. Good morning. This is Shane Silsby here with Rob Thompson, General Manager of Orange County Sanitation District. Rob was nice enough to spend some time with us today to chat about the new headquarters building here for OC San. I want to turn it over to him to give us a quick little tour and highlight some elements of the project.
Thank you, Shane, for the opportunity to show you our wonderful new headquarters building. It's a big step forward for OC San here. We used to be a bunch of small, outdated old buildings and trailers with people spread all over our 100-acre campus. We knew we needed to get people together. We want to be more collaborative like everyone else. We wanted to be inviting to the public. We're looking for a warm, efficient atmosphere, and this is the building we ended up with. We went to the architects rather than wastewater engineers, which is a big step forward for us, and they helped us sort of nail that vibe. So what you see here is the lobby of our new building. It's got that warm, inviting feel I was talking about. We want the public to know that this is their building, that they can come here and see the business of OC San, and everything is open, glassy, transparent. When you're in the office areas, open cubicle theme like everyone else in the world, getting us out of that sort of 1960s, 1970s government bureaucracy vibe and into this open collaborative vibe. So if you come with me, I'll show you some of our legacy pieces. We have a wall for history that shows where we came from. We never want to lose sight of where we came from. It helps ground us for where we're going. So you can see a lot of great old pictures here about how the facility has grown from when we were the joint outfall sewer system back in the 1920s through our development in the 50s with some of the new digesters that were built back in the 50s, our SenGen station going in, and some of the early work. All right, so what you see on this history wall is the humble beginnings of OC San when we were the joint outfall sewer. The 1920s stuff right here in Fountain Valley where the line came down from Santa Ana, Fullerton, Orange, collected all that sewage, sent it off to the ocean where it belonged back in the day. What you have here are some of the original piping construction that happened. We have some segments out front that we put out so the kids, when they're coming for the tours, can see what's going on. You didn't used to buy pipe, you made pipe. And this is how it all went together with tiles that had cement poured over the top. As we progressed, we went into primary basin installation, digester construction in the 50s and 60s, and some of the early work. As we transition, again, we don't want our office staff to become disconnected from the plants. So we actually have a bridge that goes over Ellis, allowing staff to go back and forth without disrupting traffic, without being a burden to the city. We wouldn't want somebody out there 24/7 pushing buttons to stop traffic and stop what's going on with the city. In addition, we have an educational center here. So you can come see wherever you live in our service area and how that water flows down to us at the treatment plants. We have a lot of information about how we're net zero in this building and all the work we're doing to capture energy, create energy from what we're collecting. It's all about sustainability, as we all know, and then a lot of great educational pieces for the kids as they come in to know how we treat water, what are the different parts and pieces, and how we get all the way to water reclamation.
Welcome to another episode of the Public Works Podcast, the show where we explore the people behind the infrastructure that keeps our communities running, our infrastructure connected. I'm your host, Shane Silsby, and today we're talking with a special guest, Rob Thompson, the General Manager of the Orange County Sanitation District, which we will discuss today and call OC San. They are one of the largest wastewater treatment agencies in California. Under Rob's leadership, OC San continues to innovate from a brand new headquarters building where we're filming this session today, to the use of new project tools and financing models, which we'll get into a little bit more, to delivering complex infrastructure in a way that embraces innovative technologies. We'll dive a little bit into Rob's career, his journey, what he thinks about for leadership philosophy, key projects, and how OC San is shaping the future of infrastructure, serving the public in Orange County. Rob, welcome to the show.
Thank you, Shane. Thank you for the opportunity. What a great platform you're offering, and what a great venue we have to show off.
Yes, and thank you for the tours. Stick around. We'll show some video of the tours with Rob and some of his team members that we took on site. But for you, Rob, let's start at the beginning. How did you first get into the industry? We call it public because it's kind of all-encompassing, but how did you get into it, eventually find your way into water, wastewater, and then into the sanitation district?
Well, I'm an oddity in the wastewater world because I'm an electrical engineer by training and background. I'm a Cal Poly Pomona grad. I started my career actually in the oil and gas industry. I spent the first 6 years of my career working either in refineries or in the north coast of Alaska. So literally right on the Arctic Ocean in Prudhoe Bay, working on either water handling jobs or gas handling jobs, huge projects. What was interesting about them is you built all the modules, which could be 3,200 tons, in shipyards in the lower 48, and then you'd put them on barges and ship them around only when the ice left the coast. So back then there was no global warming. Would have been great because we had to worry about would the ice clear the coast so we could get our modules in place. So it was a great learning field. I was one of 3 engineers managing $1 billion project for Ruff and Parsons Company, and it was fantastic. The problem is I got married.
Okay.
And that life really doesn't lend itself to a connected marriage and a connected family life because you're always living out of a suitcase, 18 days on, 10 days off.
Okay.
So for
me, in a
me,
different location, different part of the country potentially.
And when that project's over, you could be in St. Petersburg, Russia, or you could be in the Middle East. So for me, I needed to find a job where I could be present with my family, be with my wife. That was the big choice for me. So I looked around and said, hey, what can't be offshored? What doesn't move around? Wastewater.
Yeah.
So 30 years ago, I started here at OC San.
Okay, so you were in the private sector,
Yep.
which I think always is helpful to give leaders kind of an idea of what you're working with from your partners on the private side. So 30 years with OC Sanitation District, impressive career, just longevity. But you probably had many roles, many jobs. How did that journey prepare you to become the general manager?
I started as an electrical guy. I started as a computer controls person. I started, area of wastewater treatment, especially 30 years ago, that wasn't the mainstream. If you weren't a civil engineer, you kind of weren't in the club. So I started my journey here working with the electric plants, trying to get those sorted out. How should we be operating them? Because it was electrical.
Yeah.
And within a year, I became a manager for plant automation. So trying to figure out how to turn these completely manually run treatment plants into computer-controlled, remotely operated treatment plants was my first challenge.
Sure.
So that really consumed the first 7 or 8 years of my career. Things were going well, so they expanded it. Okay, now move into the maintenance world. Take over electrical and instrumentation maintenance. Oh yeah, and then take over the power plant. Oh, by the way, they didn't take anything away.
Oh yes, yeah. We call that accelerating your career growth.
Yes. Stretch assignments. That all hasn't changed. It's still a viable strategy, but it was great for me, and I loved it. I had that great work-life balance, and it was something I loved. So from there, I was able to move in an engineering planning world and do asset management, and then director of engineering. I went and got a civil PE because if you can't beat them, join them. You need those chops, and it was the best thing I ever did to really expand my basic knowledge of what's going on, why. I understood the chemistry, I understood the thermodynamics from my oil background, but understanding the biology and the hydraulics really rounded me out to be a more thoroughly vetted leader for an organization this big and this wide.
It's a good point you bring up. And we're about continuous learning here. That's part of what this video education is about. But also, as we took a tour of your facilities, and thank you again for your time on that.
Sure.
There's a lot of different pieces that require a lot of different expertise, right? You're not just filtering water or treating sludge. You're doing a bunch of different things on the site and building projects and have to manage and operations and all those things.
100%, yes.
So your journey gave you some of those experiences, obviously, but did you have any mentors or anybody you worked with that kind of helped shape your leadership style?
There were several, obviously, along the way.
Sure.
I could point to a few when I was in the consulting world that really helped me understand I needed to become a better generalist. You want to have value, you really have two choices. You can be that super specialist, the super tech, and be the end all in whatever field you want to be, or you can step back and say, if I want to move up and really run something of consequence, you have to understand more from a breadth standpoint. So a couple of people in Parsons really helped me understand that. Another key learning I can remember is I had a job leader. I was in the middle of a very contentious meeting between a British Petroleum executive and a Ralph M. Parsons executive, and they were arguing over scopes of work, what was included. And in that meeting, I thought I could help. And I can remember leaning forward, starting to make a noise, and I got a hand in the middle of my chest pushing me back. And my job lead leaned over and said, when elephants fight, mice get out of the way.
Okay, so
one of those opportunities, homegrown mentorship, but learning from those, not forgetting that, I think is the key. And I think somebody early on here, Don McIntyre was the first GM when I started here. And he explained to me about bureaucratic arrogance, about being that public servant who wants to help the electeds. And you can be bureaucratically arrogant and tell the electeds what they need to do. Or you can be that person who lays out for them what the possibilities are and trusts them to make the policy choice. And if you put yourself in the position of telling them what to do, or worse, manipulating them by controlling the information they have, it's not going to work out well for you or the agency. And it's one of those important mentoring moments that really resonated with me and has helped OC San as I moved up and along to really cement that into our culture. We are going to be open. We are going to be transparent because that's who we are. And we're going to trust the electeds on our board to make the right decisions. We're going to educate them. We're going to tell them all the options. We're going to tell them everything we're doing and why, but really trusting them. And when they say turn left, we're going to turn left. And when they say turn right, we're going to turn right.
Yeah, and that can be important when you're in public service and doing a lot of work that I don't think maybe the average person obviously understands. Even people in the field don't understand what is happening maybe in the plant and all those buildings and what's going in and what's coming out. So having some trust there is important because there's a lot that people don't see that in the treatment.
And that's how you build trust, is that communication and helping them understand.
For sure, yeah. So in your organization, how do you then foster innovation and collaboration with such a large and technically complex organization, and not only the organization, but the systems that they're running? So how do you get people talking? How do you work on leadership development?
It started for me way back when I was that plant automation person. When you're dealing with some old school operators, and automation back in the day meant layoffs. We're automating to fire people. So when people hear you're the automation manager, they hear you're basically the firing manager. So it took a lot of education for people to understand, no, we're going to do things differently. That doesn't mean there isn't a home for people. We may need to shift our skills. We may need to do things differently, but there is going to be a place for everybody. So you have to take away that threat early on that, yes, the only thing that is constant is change. And we have to embrace it and figure out where we want to be in the long term so people have a chance to adjust. We have a chance to morph or change our systems to meet new challenges, but we don't want to get in a position where it's a crash course, where it's an emergency, where everything's changing helter-skelter, and people don't have that sense that there's a steady hand on the wheel. This is understood. We have the money. We have the expertise. We're going to invest in you, the employee. So if you come up with a great idea, we're going to look into it. We're going to be innovative. We're going to be more effective, more efficient. and it doesn't necessarily have to have a downside. We're going to do it in a way that makes sense. We have a couple of examples, I think, to talk through on that.
For sure. And there's plenty of work to do, right? The more
Exactly.
you automate, maybe the more you can do. Maybe it was the AI of the day, right? What people get worried about. Um, for the headquarters building, which is part of change, right? Facilities get old, work environments need to adapt, what people expect from their workplace. Can you tell us for this project that we're at, the headquarters building, what were some of the goals for that project, either from a sustainability standpoint, functionality standpoint, employee experience standpoint?
Sure. So our mission statement is to protect the public health and the environment through effective wastewater collection treatment. So we wanted a building that would really model that environmental ethos. We did go with a mass timber design. It is a fantastic common sense answer to modern building purposes. Here in Fountain Valley, we're on really crappy soil. It's old riverbed. The soil's not great. So by actually moving to a mass timber building, it was lighter. So we didn't have to spend as much money in the soil treatment and the foundation work. And it allowed us to kind of offset that extra cost that comes with moving in a mass timber area. It makes for a very warm, inviting building. I mean, people like that sort of natural wood. It tells a story of transparency with all the glass that you see. It's not overly finished, so you see sort of those raw timbers and sort of that more modern look. So it created a great work environment where people are more comfortable. We fought initially when the building was being designed, no, I have an office, no, it has to be a certain way. We made the decision to move to an open layout with sunlight equity discussions about offices are in the interior, cubes are on the exterior. They get the light first. Light comes into offices through glass walls. That transparency becomes part of the culture. We made the statement up front when we move in, no changes for 6 months. Doesn't matter what it is, unless it's fire safety or has to be done, it's not going to happen. Wait 6 months. It's been a year. Everyone's fine with how it turned out. It is a better layout. It's much more modern. People are happy. It's been a really good outcome for us.
Yeah, that's great. And change, even if it's positive, can be difficult, right?
Yes.
A newer workplace is still a new workplace, right?
Correct.
And all those things. I go to a different part of the building than I used to. So going through the project and that process, can you recall any unexpected challenges you ran into or any lessons learned during the development and the delivery of the project?
Oh, we were putting this out to bid right as COVID became a thing.
So 2020, early,
Yes.
yeah.
So early 2020. I mean, one of the weird things was restrooms. If you remember early in COVID, oh, no two people can be at the restroom at the same time. It's a common vector. Everyone's freaking out. So we made the move to go to individual restrooms. And the thinking was, times are changing. Gender neutral restrooms probably going to be a thing if you're looking 70 years out. Yes, it solved the COVID problem, but we're always looking for, okay, there's a problem. What's the opportunity? What's the bigger issue? Something we never would have done. One of those weird twists and turns right at the time. This for us was different because we are a wastewater agency. We have great designers and inspectors for wastewater. This is a building designed by architects. We farmed out and got third-party construction management, which we don't usually do. That's something we hold very close because we want things how we want them. But I think we realized this isn't our wheelhouse. So let's spend our resources out working on headworks, working on primary treatment, working on automation, working on electrical buildings. Let's let the architects do the right thing here. I'm sure they'll do a better job than we wastewater engineers would.
Yeah, so that's interesting. So OC San's general mode of operations is you have your team, they're experts, they oversee the projects for you and the design and the delivery and the construction management, effectively, or the inspection. But in this case, you're building an administrative office building for people.
Yes.
That's not your team's background experience.
Nope.
Got it. Yeah. Well, that's interesting. You made that decision on a project. And I wanted to next talk about project delivery. OC San has been a leader in delivering major projects and has also embraced newer ways to deliver those projects. For listeners that may not be familiar, can you briefly explain OCSAN's project execution approach and maybe some of the new delivery tools that are becoming more popular in public infrastructure that you may have adapted here, OCSAN?
So we are a design, bid, build agency. We're very good at it. We've been developing our standards for a number of years, whether they're electrical standards, SCADA standards, civil standards. Everything in our plant operates the same, whether it's a pump station out around the county or anything in the plant. If you pull up a computer screen and see a pump, anybody that's trained on our system can operate any pump. The tagging is uniform, the colors are uniform, the symbols on the screen are uniform, the buttons in the field all have the same names. If you see one, you can operate any. So we like that level of control. We love our consultants. They do a great job, but we ask them use our standards. That's OCSAN, that's our ethos. But what we realize is there are things like this admin building, like our upcoming laboratory building, like our ocean outfall work. Marine engineering, not our strong suit. Laboratory design, not our bag. So progressive design build has come into the lexicon. We have been empowered by the state legislature to do 10 projects between now and 2030, with a few caveats about minimum size and some other things. So we're trying to be very judicious about choosing 10 projects and building this progressive design build capability. It's a new tool in our tool bag. I think there'll be a mix of things going forward. So we are getting our feet wet. We hired HDR to be a consultant for us to build the systems. We didn't just jump in and put out an RFP. We built the backbone procurement and specification libraries behind what we're going to need to do. And now we've started to roll out projects. So we're starting with the outfall system. We're moving into an electrical cable replacement system for our headworks. Then we're going to move to our laboratory replacement and an O&M building replacement at Plant 2.
Yeah, that's great. And we talked before, it's nice to have multiple tools in your toolbox, right? And progressive design build being one of those tools when you're either doing something that's not mainline or your risk is up or the complexity is way up. I mean, there might be a way to mitigate that process. Selecting your contractor team by qualifications effectively.
Yep, it's a great tool to have for things you can't dictate means and methods for.
Right?
Yes.
Yeah. Any advice? You guys have done that kind of recently in the last couple of years for other agencies that might be trying to make that transition or understand more about those delivery methods. Any thoughts?
We try to collaborate widely. We have had, like every other agency in the state and in the country, a lot of turnover. The silver tsunami. We have so many new employees coming through here. Thank you to retirees for your service. The new generation's coming in. And the upside is they're connected because they're coming usually from somewhere else. Yeah. So we're kind of leaning into those natural connections that exist across professional organizations and prior employment relationships to really build that connection to understand and learn from others. And because we're a big agency, we can share what we've learned with others.
That's great. And to deliver projects, you have to have funding, right?
Oh,
Either
yes.
your own funding through fees or whatever method, or some external funding. And the projects at the district, the numbers can be pretty large.
Yes.
And so in order to smooth the delivery of your program, have you done anything innovative on the financing side to address that?
And the answer is yes, but the more important thing I think is our planning process to get at the basis of what you're talking about. The key to funding is to know how much you need over a period of time. Avoid the shocks, avoid the big unexpected costs. It's just like your own personal finances. So what we do is we've really worked on the planning environment. We develop a strategic plan with our board. We do it every 2 years. It lays out everything we're going to do and what we want to become. It looks at all of our regulatory requirements, seismic changes and the new codes, climate change, obsolescence, wear and tear. We have an asset management group that looks at the condition of all of our assets, how many years of remaining useful life are there, and from all of that knowledge, we build a CIP that is really a 30-year CIP. We cash flow it for 20 years, and our budget shows a 10-year cash flow. By understanding exactly what we're going to do, when we're going to do it, and how much it's going to cost over that 10, 20, 30-year cycle, we can build a rate structure that allows us to be a pay-as-you-go agency. At this point, we are pay-as-you-go. We have some existing bonds from when we went from partial primary treatment to full secondary treatment. We have about $600 million in debt. That debt should be paid off by 2040. We have just finished refunding some of that debt. And because we have a AAA rating from all three rating agencies, we're getting very favorable interest rates. The last one we just did was an effective interest rate, I'll brag a little and say 2.66%, because we have that AAA rating. It just makes for, in this case, a $16 million savings on bonds that we had anyway that will mature in 2039, saving us $1 million a year, basically freeing up that cash flow for more projects, for more maintenance.
And that helps stabilize the rates for your ratepayers in the service industry. Some analyses that I've done recently for other agencies was that the consumer price index was averaging year over year about 3 point something. The California construction index was about 5.5% year over year on a trend. So an interest rate below 3 is really an advantage to your service area.
But we're also projecting rate increases for that time. We believe in consistent, steady rate increases. Don't stop raising your rates. So we intend to raise our rates 3.5% for the next few years, maybe up to 5% long-term, year in, year out, to keep up with inflation. If you don't, you end up with underinvestment because you're trying to cut projects to meet your cash flow. We want to do it the other way. We want to say, what do we need to meet our mission? And then put a rate in that matches that, and not do a bait and switch with our rate paying public, but be honest with them about how much should this cost over the longest period of time, and how can we provide that service as efficiently and effectively as possible to maintain that 3.5% to 5% rate increase every year and keep delivering more and more value.
Sure, and you have to operate and maintain all that equipment. If you're not doing that at a certain level, it starts to degrade, your efficiency drops, and then in the long run, it could cost more.
Always does.
Yeah.
It always, emergencies cost more than planned replacements.
Yeah, and in the background, costs are going up anyway, inflation, labor,
Right.
all of that. You mentioned a little bit about your asset management plan, which I'm going to ask you about in a minute, but a couple of key projects rolling out from that plan into your capital improvement program, or what we call the CIP. You mentioned a couple of those. I wondered if you'd talk about the first one being the Seal Beach Pump Station Replacement Project. Just a quick highlight on that. We might be lucky enough to get some tours of these facilities, but anything you want to add about that project?
So the Seal Beach Pump Station basically conveys all of the sewage coming down the western edge of Orange County along the Coyote Creek area into the Seal Beach area. It pumps the water across along a couple of force mains over to our Huntington Beach facility. What we've looked at there is this facility was put in place way back in the 1960s in cooperation with the Navy. It's on the edge of the Navy base, and it's reached the end of its life. It's got mix-mash pumps that don't really work together well. It was never really designed as a coherent facility. It was just kind of grown over time. Because of the condition of its concrete, because of the condition of the steel, and an opportunity to change the hydraulics of the station, we're going to replace that station in place, make it a little deeper, and that will allow us to actually get rid of a pump station upstream of it. So yes, it'll cost a little more to go a little deeper, but long term, we're going to lose operation of a whole pump station at the West Side Pump Station.
So your operating costs are going to go away for that facility.
Correct. Yeah. But the trade-off is we have to do a deeper plant. The interesting part about that location, it's right next to where the old Saturn missiles used to be made for the Apollo project. So the groundwater is completely tainted. All of those solvents they used back in the day, the good old days, we were prevented from having any water movement. So one of the interesting pieces of that job was we had to design to build a deep pump station without dewatering, because we aren't allowed to move that plume anywhere. So we had to be innovative. We looked at everything from soil mixing to structures to actually freezing the ground and creating a frozen barrier while we did the construction. So a lot of what we do, we're always looking at that innovation. What's out there? What are the new techniques? And which one best serves this project? So that's one of those cool projects where we had to be innovative. Otherwise, it just would have been too expensive.
Yeah, and so innovation is a constant theme we're hearing about on our tours
Yes.
today. Anything you wanted to mention about the Bay Bridge pump station might be unique about that?
So the Bay Bridge pump station is on Pacific Coast Highway, where there's a bridge obviously going over the Back Bay access, San Diego Creek area. Well, we have two force mains along with that pump station that are years old, 1966. The area has grown, the pumps are at the end of their useful life, and the force mains are at the end of their life. So that's an interesting project because it's about microtunneling to put in
Mm,
new force mains under the bay, as well as replacing a pump station while the current pump station is still active. A lot of tight work, a lot of thoughtful design has to go into each aspect of executing that project.
that's great. And thank you for that. You have a lot of interesting projects on the capital improvement program, but maybe the last one to discuss while we have time is the Ocean Outfalls Rehabilitation Project. And so two interesting projects already, maybe a
Yes.
third one. What's up with this project?
So the ocean outfall is probably, in my humble estimation, one of the most important assets for Orange County. It's a 120-inch pipe that goes out 5 miles, 200 feet deep, and that is the main disposal point for all treated wastewater in north central Orange County, as well as for SAPA, the Santa Ana Water Project Authority, in the upper basin. Western Municipal Water District, Eastern Municipal Water District, Inland Empire Utility Agency, and the San Bernardino Valley Water District can send OC San salt-laden or briny water that's kept out of the Santa Ana River. That means salt water doesn't end up in Orange County's drinking water supply. All of that water has to be disposed of in the ocean. So this pipe, 10-foot diameter again, 200 feet deep, 5 miles long, super important pipe. It's been in the water since 1971.
Oh, wow.
Went into service. Installed in the mid 60s. It took years to install. This is a really important asset. We have to do work on it. Some of the steel that's been under there has been down there since the mid 60s. So we're replacing all that connecting steel, all the manhole access points. So for us, we're not a marine engineering specialist. So this is one of those places where progressive design build makes all the sense in the world. Let's get people who really are experts in this. They understand the risks, right from how do I do work on this structure when I'm on the ocean during a large swell. If we do the design, then what we always hear is, well, sorry, couldn't do the work, there's a swell on the ocean. Our line is, I don't care if there's a swell or not, figure out how to do your work so that's mitigated.
Right.
That's what we're looking for, is someone to have that means and methods and partner with us to manage the risk, get the work done, and make sure the crown jewel that is our outfall is safe and effective for another 25 years.
Yeah. Another really interesting project that I think, and I live in that community. I kind of see the infrastructure a little bit, but I don't really know what happens beyond that.
Right.
You're doing a lot of work for people that they don't really understand. All they know is, when they flush, goes away. Yes, the magic happens.
I never want to think of it again.
So, looking ahead for OC San, maybe the next 5, 10 years or so, we've talked about some of the current priorities, but as you look ahead, planning, innovation, a couple of things I want to just ask you about. One is your asset management planning process, how that informs your CIP. You've brought it up a couple of times, but can you just explain how you ended up going in that direction and how that shapes the priorities going ahead?
As I discussed, I came through the organization. One of my stops was the engineering manager for asset management way back in 2010, 2011. Then it was consolidated with the engineering planning group. So we turned asset management into the engineering planning system. And the important thing is that asset management not be something separate. Anything we do, we can talk about the machines and how the machines work together, but we need to make sure the people that are OCSAN also work together. I think there's a clip that you'll show where we were out in the field. There's a problem with our dewatering system, and who shows up? The lead operator for process, the lead mechanic for that area, the asset manager, supervisor, and the asset manager for that area, and a process engineer. When we have a problem at OC San, it becomes who owns the problem. And for us, we created a group in the engineering planning department where it's called asset engineer by title. And that asset engineer is the owner of the system. They're there to support the process team that's making it work, the lead operator, the lead mechanic, the lead electrician, the lead instrument tech. But the asset engineer is the one I'm going to look to say, what broke, why did it break, and why didn't you know? They have that ownership, responsibility, and obligation. Projects come and go, but who owns the system and who's setting the importance and the goals moving forward? That's the underlying basis of the system. Now, there's a report that the asset engineers produce, and we do that annually for our headworks, for our primary basins, for each of our secondary treatment plants, for our solids area, for our dewatering area, for our power generation system. There are owners, and there are existing parts of the plan that say, what are the projects that are ongoing? How much remaining useful life is left for each of those areas, down to sub areas and subsystems. So we know where we're at. We aren't just throwing basic dollars or estimates at this. We actually have engineering understanding of the condition, what we want it to become from our strategic planning, and how we're going to get there. So that kind of gets us into, why would we look at biosolids right now? And the answer is because those are the next projects on the horizon. Those are the ones that are 5 years, 10 years out. I don't want to start innovating on an area where I'm already in design. It's too late. Everyone executing projects knows you've got to know what you're doing before you start the project. Yes. So the project CIP schedule is really determined by the asset plan and the strategic plan.
Yeah, that's great. And for government agencies or pseudo-government agencies, I'm always a big proponent on alignment of the teams so that everybody knows where they need to go, and therefore you can get efficiency and effectiveness of their delivery.
They have to be mutually dependent is another thing we've designed in. Nobody can go it alone. We took all the engineers that were in maintenance doing little projects to help them. We took them out and put them in asset management. So the groups become dependent on each other. They can't go alone. They must work together.
Oh, that's great. And that's a great way to try to deliver the technologies you have today and looking ahead to tomorrow and planning that out. But OC San, under your leadership, has also been innovative in other areas that are not mainline, are not mainstream. Mm-hmm. We toured one of the sites for a future demonstration project. I know you're excited to talk about this. Over the years, you and I have talked about it. Supercritical water oxidation.
Yes.
And so would you please explain to the listeners, what that thing is, how it came to be, and maybe your involvement in it?
Sure. We at OC San are always looking for a different way. And I think that's a function, again, of me being an electrical engineer, somebody who came from outside this industry. I wasn't trained on how it's supposed to be. Mm. I didn't come in with a preconceived notion that it must be a certain way. I certainly learned how they do it, but there's a certain thinking that develops when you're told, here's your problem, here are your rote steps. We all kind of learn it in engineering school. Being the person that was a little out of my educational emphasis allowed me to kind of ask why. Why do we do it that way? Why do we do it that way? When I went to Parsons, you had two choices back in the day. You could either go to oil and gas or what they called their systems group, which is working for the government. One of the biggest jobs they had going was chemical weapons disposal. Mm. And supercritical water oxidation was one of the technologies that they used to destroy some of the particularly nasty chemical weapons. So I was aware that it existed. I had talked to people. I was looking at the processes going on in refineries. And so I had that natural curiosity. What is this? How's it work? Oh, that's great. Probably never use it again. Mm. Well, fast forward a few years, we team up with a company called Isle out of London, England, and their job, as they see it, is to partner with people to bring in new technologies. Let us show you what's going on. And they showed us a company called Aquacritox, which did supercritical water oxidation in a different way. It turned out that their method wasn't prone to success, is a nice way of saying it. If you take sewer sludge and you heat it and pressurize it, you end up with a really complicated tarry goo that clogs everything. And their idea was to do that and then put in liquid oxygen. And you could destroy all of that. Didn't really work. So one Christmas period when you're cleaning out your desk and all those magazines have been piling up. You're kind of, I want to throw this away. Looking, I saw an article on SQO, supercritical water oxidation, and the idea wasn't to heat and pressurize your sludge and inject oxygen. Their idea was superheat air and put biosolids into it, and it'll instantly go supercritical and instantly oxidize. Once I saw that, it was that slap the forehead moment. Aha, why didn't somebody think of this earlier? And that started us to move down the path of, let's investigate this, let's go see it. I went to Duke University, where they had a 1-ton unit being demonstrated, funded by the Bill and Melinda Gates Foundation. It worked, and we started on the press 4 years ago now, and we're very close to delivery of a 6-ton unit for biosolids here at OC San.
Yeah, interesting. I remember you showing me some pictures of your visit to Duke when you were interacting with kind of the byproduct streams and just showing how it wasn't harmful to humans.
Water, nasty sludge in, and basically pure water with some dissolved salts in it on the way out.
Yeah, that's great. So we're excited to learn more about that. I know you'll probably be pushing out information as you start to demonstrate that project here locally. Thank you for your leadership on that in Orange County.
Happy to do it.
Yeah. So this has been a great conversation, and I thank you again for your time on the tours today and meeting with your teams and touring the building. It's been great. Wanted to get your thoughts on some final questions here, your insights and experience, since you have such a great career and with OC San. So quick hits here for you. What's one piece of advice you'd give to someone starting their career in public works or this industry?
Go wide. Understand technology. Be curious and delve into things. You have an opportunity to learn anything with the internet. When I started in the 90s, you had to do work to learn things. So spend the time, make yourself nice and wide, understand lots of different technology. You don't have to be the end-all expert, but understand how they can affect each other and look for new ways to deal with new problems.
Good point. So generalist is okay, right?
That's right.
And with your background and what you've been doing in innovation, I'm interested in your response here. If you could instantly solve one challenge in public infrastructure or the delivery of services through infrastructure, what would that be?
Yeah, I gave that one some thought, and I think if I could snap my fingers, I would really love for us all to have perfect as-built information and perfectly collated data on how things were operating and what condition it was in. I mean, the biggest thing keeping us from really taking advantage of AI is the condition of our current data sets. If they don't match, it's garbage in, it's garbage out. When you're digging in the streets, wouldn't everyone love to know what they were going to run into before they ran into it? If I could snap my fingers in the most simple way, just tell me what's out there with complete knowledge.
So the roads would be transparent. You could see what's there, or the landers. That's interesting. That's a great response, actually, which not only your agency would be advantaged by, everybody would be. That's great. We've covered a lot of things today, both on the tours and with your conversation. Is there anything you'd like to add for our listeners to consider that we might not have covered in our chat?
I think each of us working in this industry have an obligation to those we serve to be effective, to be efficient, to take calculated risks, not wild risks, not stupid risks, but calculated risks in full transparency. Ask your board or your city council or your governing body, whatever that is, explain the risks, explain the opportunity, and make calculated risks to make everyone's job better, to move us forward. Because what got you in your current spot isn't going to get you to the next spot. Be innovative, connect the dots, and really be open to asking why not. Don't just ask why not.
Yeah, good point. And innovation in government is something sorely needed, right? So that's great advice for our listeners. So with that, I want to thank Rob Thompson, the General Manager of the Orange County Sanitation District, for joining us today on the show. I appreciate him being willing to spend some time to share your experience with the Public Works Podcast. To our listeners, thanks again for tuning in. Be sure to subscribe, like, share, check out more episodes, more sessions of the show, where we have conversations with people in the industry who are keeping our communities moving, connecting infrastructure together, making great decisions to keep our infrastructure safe and the water we drink in this case, or what we have to dispose of. Until next time, please stay curious. You mentioned this, be innovative, stay curious. Rob, thanks for being on the show, and thanks for helping us build better communities.
My pleasure. I love my job, and I'm richly rewarded for it.
There you go. Until next time, thank you.
So here we are at our headworks. This is the beginning of the treatment plant. When we talk about public works, this is why we exist. We have wastewater coming in here from 2.6 million people in Orange County. Here at Plant 1, all the water is going through these 4, soon to be 6 bar screens. They're 5/8 of an inch apart. Anything wider than 5/8 gets caught, separated out. So everything from bicycle frames to lumber, bowling balls, all of those sorts of things get trapped here. What you're going to see coming up is really the deuterium of humanity. This is what anybody can flush down a sewer pipe. So we never want to get far from where we've come from. This is why we exist.
And Rob, we have a little aroma in here that you can't smell on video, but we're in it here, right?
Oh, we're in it. This is the real deal. All of this air is scrubbed. We prevent all these odors from escaping the building. The important thing is that to be a good neighbor, everything's sealed, all the air is captured and sent to scrubbing systems on the outside, which I'll show you. So here we are on the outside of the headworks area. OC San does something a little different than most other agencies, especially in our area. We believe in an active asset management system. So every area of our treatment plant has a plan. This headworks is where the water comes into the plant for the first time. It gets screened, it gets lifted, it gets grit removed, but this area wears out, just like every other area. Headworks, primary treatment, the 3 secondary treatment systems here, power systems, solid systems. Each of those systems has a plan, and once every 30 years, we do a massive project to renew. We look at seismic risks, we look at obsolescence, corrosion, erosion, climate change issues. All of those things are captured, and we do one project to get everything back up to where it should be. So this is a $222 million project over 6 years to completely renew our headworks. After the project's over, we'll put it in service, we'll do our maintenance, we'll squeeze 30 years of life out of it, and hit it again in 30 more years. We're here inside OC San's lab. It's a fully functional lab. We do more than 100,000 samples a year. We take water from the treatment system, we take water from the beaches, we take water from influent. We make sure that the water that we're treating doesn't have any unnecessary or toxic chemicals that we can't deal with, and we make sure those things we can deal with are being fully treated and taken care of. So there's a general chemistry lab, there's a microbiology lab, analytics. We have all sorts of crazy, expensive gas chromatograph type machines, all of it in here to make sure that the water we're producing is safe and clean, and we've done our job correctly. As we look into the lab, you can see they've just received some ocean samples. They're going through the process of making sure there is no fecal coliform in the ocean. Our job, our mission is to make sure the public waters are safe. That's the first part of our mission statement, to protect the environment and the public health. This building is great. It's serving our purpose. However, it is getting a little long in the tooth. Science has moved a little ways from the early 1990s when it was really designed and built. We're upgrading it to meet all the new standards, create the right atmosphere and environment for us to get better, more complicated labs. No one ever would have thought you could measure parts per trillion in 1990, and now it's done regularly. So we have to keep up. Progressive design build is a great way for us to update a building of this type. It's not our wheelhouse. We're great at wastewater design. We're great at concrete and steel. This is not that. So PDB is another opportunity for us to execute differently and do things, I think, in a more nimble fashion and get a better outcome.
All right, we're here in the OC Sanitation District laboratory. We've got some special guests we're going to hear from next. Brandon, tell us what's going on here, your role with OC San, and what you're up to here today.
My name is Brandon Yokoyama. I'm an environmental technician for the laboratory, work in the Gen Chem microbiology group. Today we are processing surf zone samples. These samples are taken from Seal Beach, near the San Gabriel River all the way down to Crystal Cove State Park. Right now we're pouring out all the samples for part of the membrane filtration, which is fecal indicator bacteria tests that we do twice a week for OC San.
Okay, Brandon, why do you do this?
It's part of our MPDS permit. We have an obligation to check fecal indicator bacterias at our specified locations throughout the surf zone in our service area, and even outside of our service area a little bit.
Yeah, it's a safety issue, right?
Yep.
And Brandon, how long have you worked here at OC
I've
San?
worked at OC San 22 years, going to be 23.
Okay, so
Yep.
you know what you're doing. You know what you're talking about.
Yes, I hope so.
Great. Thank you very much. Okay, we're continuing our tour with Rob. We're under the primary basin, underneath a lot of stuff here. I'm going to let Rob take over and tell us what's actually going on.
So these are our primary basins, 6 through 31. This is where the bulk of our water treatment happens. A lot of people look at an aerial photo of the plant and they say, wow, that's a big plant. It's 110 acres. You have all these things. But what they don't see is what's underground, what's buried. And that's an important part of understanding how big the infrastructure here is and what it takes to treat all this water. Each of the primary basins goes out laterally. You can see down there, side to side. All the water comes in over our head. It spreads out, gets treated. And what you see down here is all the sludge pumping that has to occur. As the solids settle out, they're pumped to our digestion system. The digesters convert all the sludge or scum we collect and turn it into energy in our central power generation plant. The heat from the engines heats the digesters. The energy that's created, the gas that's created, is turned to electricity, and we make about 2/3 of our power need. We work really hard to keep the plant clean. It's safer that way. It's more effective, more efficient. We know the condition of our assets because we can see them clearly. We don't let things get cluttered up. We make sure that we have a good, safe, clean work environment.
We're in a tunnel here, Rob. So how long do you think this tunnel was that we're in? Probably 2 or 3 football fields?
It's 2 football fields.
Yeah.
You couldn't throw a football that far, not even Mahomes.
There you go. Thanks. So there's the tunnel we were just in. You can see we're underneath these huge basins as part of the treatment process. Okay, Rob, what are we seeing here now as part of our tour?
We're at the back end of our plant here in Fountain Valley. This is our activated sludge plant. Activated sludge is sort of an old moniker for a biological treatment system. What you see here, never let anybody tell you you don't have a lot of fun at a treatment plant. This is called mixed liquor.
Mixed liquor. Okay.
The mixed liquor is really all about the microbial body that we're keeping alive, and we're feeding the pollutants that are in the water, all that extra organic mass. That's what you're seeing here. There are microbes eating whatever impurities are in the water, and that's their job. Our job is to feed them impurities, give them oxygen, and let them do their thing. All of that has come from our reactors, which do the biological treatment. This is where we settle out what we just created. We want those microbes to work again and again and again and again. They're going to get 10 trips through this on average over 10 days. They're going to settle out. You're going to see how primary or secondary basins work. All the microbes have settled out. This is what an empty one looks like. You can see the baffle walls, which prevent any kind of movement of water. Everything settles out and gets returned back to work. The water is then cleaned through gravity. Anything heavy goes to the bottom. Anything light comes to the top. These bars move very slowly. You can see on this side how they slide on nice Teflon coated slides. But anything on the top is being trapped up against this wall up in front of us. The water spray is in place to keep anything that was floating trapped up against the wall. The valve will lift. All that floating debris will get caught over a weir wall, which you can see on this empty side. All of that gets returned to Headworks and cleaned. What you're left with after the water goes under that structure is nice clean water coming through our V-notch weirs. This is the water that we're returning to the Orange County Water District. They're turning that water into Orange County's drinking water. This is our product water heading across to be further treated by the Orange County Water District. And what we have is something that the employees have created over time. This is a little spot where we have some koi. See if they'll play ball with us. There are koi fish in here as well as some turtles.
Great. Anything we missed on this part of the plant?
No, this is the money piece of the work. You saw the dark water, it's ink-like when it comes in. This is our product water, safe and clean, ready to be made into drinking water or to be safely disposed of in the Pacific Ocean.
Hello, this is Shane Silsby again on site at OC Sanitation District, and I'm here with some special guests as part of the Public Works Podcast Tour. So April and Ernesto, thanks for being here today. April, please tell us your name, what you do here, and then what we see behind us, and then Ernesto, if you could fill in the gaps after that.
Sure. Hello, everyone. My name is April Frost. I'm the Chief Plant Operator for Plant 1 facility at OC San. What we're looking at behind us here is our thickening and dewatering building. Inside, we have two different sets of centrifuges. We have a thickening centrifuge, which will take solids from our primary process as well as our secondary process, and we thicken them up before we send them over to digestion. Once it's come through our digesters, that flow will come back, and we go through dewatering centrifuges, which we're trying to get as much water out as possible prior to loading them onto trucks to be taken off site. This is a key area of our solids handling process.
Okay, great. Thank you, Ernesto. Tell us what's going on.
Hello, my name is Ernesto Castro. I'm an operations supervisor for process for solids. I think April pretty much covered what this building does here. But for the process of dewatering, with the amount of the percentage of cake we get here, it has to be shipped off site. And if you look behind us, we have our facility of truck loading where we get about 15 to about 18 trucks 6 days a week, and we ship biosolids out.
Ernesto, my son just had a birthday, and we had cake at the birthday. You mentioned cake. What's the difference there? What kind of cake are you talking about?
Well, I'm pretty sure at one time what's in there was cake. No, but we call it here cake because of the way we thicken it. It's usually the solids that come into this building is like a 3% density. It's like a liquid, has some solids. But when we bring it to this facility here in dewatering, we add polymer and the centrifuges operate where they thicken it. And it looks like cake. Some people call it brownies. But we stuck with the word cake a lot.
That's good.
Ernie mentioned that it's coming in at about 3%. Using these centrifuges, we're able to actually bring that up to about 25%.
Great. And then as we wrap up, Ernesto, how long have you been working here?
Oh, I love it here. I just came up my 18th year in September. This is a great place. This is probably the third wastewater treatment plant I've worked at. I worked at a couple of agencies up in Kern County. I've worked for another agency down south. I found a home here. It's not just what we do here for the environment, but for me, it's the people I've met here. I've learned a lot. I've grown a lot with people, and this is a great place to work. April, she's my boss. I say the word boss, but she's my leader. You know what I mean? She's really together, and with the team that we have, this is why we're a world-class agency.
Thank you. Appreciate that. April, real quick, how long have you been here at OC San?
I'll be coming up on about 12 years at the end of this year, and I can't agree more. What sets us apart is we have an amazing team here. It is the best place to work. We get to work with amazing people, doing an amazing thing to help protect our communities and our environment.
Thanks so much for your time today and all your work here. Really appreciate it.
So really quick, we interrupted you.
Yes.
You were meeting with the asset management team to solve a problem.
Yes,
Can
we
you
are.
quickly say what that problem is and how you work together?
Sure.
Right now, we actually here with asset engineering. We also have our process engineer, people that work boots on the ground. We have a maintenance supervisor, and we got together. We set this meeting up because we have a foul air removal here also. Foul air is produced. We got to treat it. So we're working as a team. We're getting all together, and we're trying to figure out how we can solve and troubleshoot. We're getting liquid in our lines, So we're going to work as a team. That's why you have asset engineering and you have process engineering and everybody involved. We're going to try to figure out how we can pull foul air and try to reduce the centrate and liquid that's blocking our lines.
Okay, we're continuing our tour here on the site of OC Sanitation District's campus. Rob was nice enough to spend some time talking about the innovations that OC San is working on. Rob, what's going on from an innovative side at OC San, and then what are we seeing here in the background?
So our big focus right now is on solids. What are we going to do long term with the biosolids we create? Right now they're used exclusively for agricultural reuse. So our biosolids come out, as you just kind of heard us talking about. They're a great nutrient, a soil amendment. We either compost them or put them on farmland directly for non-food crops. Great use, great reuse, circular economy, everything's great. The issue we're facing now, though, long term, PFAS has become part of everyone's lexicon, as is microplastics or pharmaceuticals. So those things exist in the biosolids, and long term, we need to make sure that we have an outlet for those biosolids. So we're looking at two technologies here at OC San. The first is supercritical water oxidation. It sounds complicated, and it kind of is. It was a technology first used to destroy chemical weapons. So you take the fourth property of water that nobody ever talks about, which is its supercritical state. It's not ice, it's not liquid water, it's not steam or vapor, it's supercritical. Above 374 degrees Celsius, above 3200 psi is this weird state of water where oil and water mix. You can use that property at temperature and pressure, mix it with some air, and you can directly oxidize or you can directly burn wet sludge. So you don't have to dry it, you don't have to deal with the grittiness of it, you don't have to deal with the air emissions that are caused by combustion. You can directly oxidize all those organic compounds, which are carbon-hydrogen bonds or carbon-fluorine bonds. The technology has the ability to destroy all PFAS.
Rob, once it gets burned, what are the byproducts of this process?
What you're left with after this complex hydrocarbon gets oxidized, you end up with carbon dioxide, water, like you would in normal combustion. You get some excess nitrogen, and you get lots of salts. So those fluorine molecules that are floating around that used to be in PFAS, they combine with calcium, so you get calcium fluoride. Your phosphates get tied up with the calcium. All of those things happen. Nothing magic, but what you end up with is a bunch of benign products that are either carbon dioxide or some sort of salt, which can be a fertilizer because it's high in potassium, phosphates, all those things you'd find on a fertilizer bag.
And then what is the district doing here in the background to prepare for that effort?
So what you see here are two pads that are poured. We expect to receive in December 2 shipping containers, one with a pre-processing unit hooked up to the 3 kinds of material we're going to test: biosolids, raw sludge, and food waste. We allow the system to screen them out, make it nice and homogeneous. We grind it all up. We send it over to the processing trailer, which is a separate container, and that's where the magic happens. 6 tons a day of this solid will be converted to those benign products: carbon dioxide, water, nitrogen, and some salts.
That's great. And then when do you expect to work on all this? I know it's a new, innovative process, so time is not really the issue. It's getting it right is the issue, but when do you think all this is going to happen at OCC?
We're going to see the first fruits in the start of the calendar year. Through the spring, at least 1 year is planned to make sure that this is a good industrial machine. Then we'll talk about whether we can upsize it or how we're going to utilize it. The next thing that we're doing is deep well injection. The idea there is you never want just one outlet. So SQUO's great. We're going to pursue it. We're going to see how it works, but we're also going to look at deep well injection, where we take our biosolids and inject them 5,000 feet down under the plant through all the water layers contained safely, through several layers of shale rock and sandstone, till we get to a target layer between 2 shale layers at 5,000 feet deep. We then go sideways, we bust up that sandstone that exists between the shale layers and inject our biosolids. It becomes a natural digester, just like we have off in the distance. Those are our digesters. Nature is going to do the same thing. It's going to turn those organic compounds into carbon dioxide and a little bit of H2S, some things down there. But carbon dioxide and methane are the main byproducts. The upside for us is it's also a forever home for those forever chemicals. like PFAS. It's down there locked away between two rock layers, never to come up to the surface again. We think it's a great way to reduce trucks on the street. All those trucks you heard Ernie talking about leaving the facilities, 25 a day, no longer leaving, no longer clogging up the freeways, no longer emitting diesel emissions all the way to either Yuma, Arizona, or Barstow or Bakersfield. So it's a significant improvement to the environment and it should save us some money.
Thank you. All right, we're continuing our tour here of OC Sanitation District with General Manager Rob Thompson. Rob, what are we seeing here and what's this dividing line in front of us?
Where we are is the boundary of Orange County Sanitation District's plant on my left and the Orange County Water District on my right, which you're looking at now. We showed you where the water all gets treated. All that hard work is done for the solids, and then all the light work is done. I'm just kidding. All the work is done to polish the water here on the Orange County Water District side. After we've done our preliminary, primary, and secondary treatment, they have begun to do their microfiltration, which we just passed. We're moving further along. They have a transfer station to their reverse osmosis system, and then the water goes through UV disinfection. At that point, the water is so clean and so pure that it's aggressive for their pipelines. They add in a little calcium to make sure the water has enough hardness to be stable and not aggressive. All of that water is put back in the ground, either through a barrier well system, which prevents ocean water from coming into this huge aquifer that we're sitting on, or they pump it up to the Anaheim Lakes area and all of it's naturally percolated in. This is indirect potable reuse. It's the safest way to reuse the water. It gives us a nice environmental buffer between anything we're doing here and what's pumped and used in the city systems at large. It's a wonderful opportunity for us to provide what was wasted as an ocean discharge and turn it into drinking water again for 1 million people here in the county. It's the best quality water that we put in our aquifer. The aquifer, by the way, is a great distribution system. It is shared across the entire north central part of Orange County. Those 20 cities all put their straws in the form of wells, and we get free distribution across the entire system. That's all managed very well and has been since 1933 by the Orange County Water District. Again, what makes us so special is the partnership. We have dialed in that teamwork. We don't worry about our cost versus their cost. We take their solids that they separate out for free. We give them the water that we're treating for free, and we actually cooperate on the capital costs up front. So it's good for the people we serve, and it's good for the county. Therefore, we're both in.
That's great, Rob. And how unique is this to have a situation where you have a facility, such a large facility, doing all this work on one side of the road effectively, and then the water district just across the street on the other side? That seems pretty unique to me.
It's one of a kind, and it starts from board leadership all the way down to the staff level. People don't see a dividing line. As we drove along, you didn't see a gate, you didn't see a fence. It's because we see ourselves as one continuous process. We start the work with source control and our treatment, but they finish the work on their side. And as we come across things that are a problem that we have to address, as technology changes, as regulation moves, we work together to find the cheapest solution for those we serve.
This is what we call the one water solution, right?
Correct. Circular water economy.
Yeah, thank you. Good work.
A lot of what makes OC San special is the groundwater replenishment system. It's our groundbreaking cooperative project between Orange County Water District and Orange County Sanitation District. We take all the wastewater that's reclaimable from 2.6 million people, we treat it and make it available to the Orange County Water District. Here at Plant 1 in Fountain Valley, we have 3 secondary treatment plants, Trickley Filter, 2 AS plants. All that water is being brought to this one central location. This is operated by the Orange County Water District. We actually take water from our Huntington Beach plant now. We pump it up here. They have access to about 170 million gallons of water a day, which they take. We'll head across, but you'll see where their facilities can take that 170 million gallons we give them and turn it into 130 million gallons of drinking water, enough for 1 million people here in Orange County.
That was Rob Thompson, General Manager of Orange County Sanitation District, sharing his journey, insights, and innovative ways that OC San is delivering critical infrastructure for the people of Orange County. I really enjoyed hearing Rob's perspective on leadership at the agency, the vision behind OC San's new headquarters building, and how they're embracing new alternatives which are impacting the way in which major projects are delivered. His approach is a great reminder that public works is about more than pipes, pavements, and plants. It's about people, collaboration, and creating long-term value for our communities. If you enjoyed this discussion, be sure to follow and subscribe and like the Public Works Podcast wherever you listen, whether it's Spotify, Apple Podcasts, YouTube, LinkedIn, or your favorite platform to listen to podcasts. Thanks again to Rob for having me on site, doing tours with his teams, checking out the facilities, and learning more about OC San's operations. If you know someone who's passionate about infrastructure leadership or innovation in the public sector, please share this episode with them. You can also connect with me or the Public Works Podcast on all these platforms. Shoot me a note on LinkedIn to stay updated on upcoming guests and episodes. Thanks for listening. And remember, great leaders providing great public works projects and services are the foundation of great communities. Thanks again.